Okay, so how we're going to do this, if we're given some points and we were on to write this equation of a parabola in standard form, we're going to plug it into a matrix and find determinants using the cofactor method. Okay, it's amazing that this works, but it does to write it for a parabola. So what you need to remember is the general form for your parabola that opens up or down. We have an x squared term, we have the points x and y, and then we have this column of ones. Okay, we have a 4x4 matrix that we are creating. So what we do is we take the first point and we plug it in, of course, here into this column, the x column and the y column, and then we square the x value to get this. So 1 squared is 1. And then we move over and we do the next points. The x is -3 and the y is 8. And we square the x, -3 squared is 9. And we do the same thing with our last points. You have the x and the -1 is the y. And we square your x value and you get a 9. Okay, now if your parabola opened up right or left, we would change this column to a y squared column, and you would be squaring the y values in order to go here. Okay, that is the only difference between a vertically opening and a horizontally opening line. So now we have to find the determinant of this matrix. So we use the cofactor method, which means we do x squared times the derivative, rather the determinant of what happens when I take away this column and I take away this row. So I find the determinant of 1, 0, 1, -3, 8, 1, and 3, -1, 1. Okay, and then I subtract x. This is the cofactor method. So I take away my x column and the top row, and I find the determinant of what's left. So that would be the left row, or rather the left column, the third column, and the fourth column. And then I add the y, so now the cofactor method to find out. So now I take away the y column and the top row, and I find the determinant of what's left, which is the first column, the second column, and the fourth column, 1, 1, 1. Okay, now I'm going to use a calculator, of course, to find all of these, but there's also, you could do it by hand if you wish, but we're going to use the calculators in a second. So then the last one is -1, and we take away the fourth column and the top row, and you find the determinant of the matrix that's left over. Now, I'm going to pause for a second and do all this fantastic math, and I'll be right back with the answers. So this gives us -12x squared minus plus 72x minus 48y plus 60 equals 0. Plus 48. This is a positive 48 here. Deal. So now I'm noticing, hopefully you are too, that each of these terms is a multiplier of 12. So to simplify before I have to do anything else, I'm going to divide everything by -12. Okay, it gives me a positive x squared, a minus 6x, a minus 4y, and a minus 5 equals 0. So this is actually a -60, or rather minus, because this is a positive 60 determinant, and we have a minus in front of it. This makes us a plus 5 here. Now to complete the square. So standard form for a parabola that opens to the up and down is x minus h squared equals 4p times y minus k. So this is what I want my equation to look like. This is what it looks like now. So I have to complete the square in order to find one factor squared for x, and then I have to find some common factors over there for the y. So to do that, I get my x stuff together on one side, and I'm going to move my non-x stuff to the other side. So I get x squared minus 6x plus a box. So this is what I do when I complete the square. I add something over here, equals 4y minus 5 plus that same box. And I think I'm off my screen now, but I just added a box to the right side. So what number goes in the box is the question mark. And how we do that is we take half of this term and we square it. So half of this is 9, or half of this is 3. 3 squared is 9. So I'm going to add 9 to both sides in order to keep my equation balanced. So now these three wonderful terms are now a perfect square trinomial. And I can factor it to x minus 3 times x minus 3, which is x minus 3 squared. And on the right side, I have 4y plus 4, because that's what negative 5 plus 9 is. Okay, so the left side looks exactly what I want, and the right side is pretty close. So if I were to factor out a common multiplier here, that leaves me with 4 times parentheses y plus 1, and now it is exactly how I need it to look. So this is my standard form for the parabola that opens up, that goes through the points 1, 0, negative 3, 8, and 3, negative 1. So it looks like 3, negative 1, well, this one must be your vertex. Right there, check. There's your vertex, 3, negative 1. Now what about your focus? Where is that going to go? Let me create some more space here and erase some of this other jibber jabber. Our focus is p units away from your vertex. So we use this equation, your 4p, 4 times p is a number in front of your parentheses. The number in front of your parentheses is 4. So if we want to figure out how far away your vertex is from your focus, we set up and solve this cute little equation. So your focus is 1 unit away from your vertex. Now because this opens up, it's a positive x squared, or rather a positive p-value. That means that the focus will be 1 unit above the vertex. So if that's true and your vertex is at the point 3, negative 1, that must mean your focus is at the point 3, 0. There's your focus, there's your vertex, there's your standard form equation.